Good morning, students. Myself, Dr.T.VINOD Kumar, Associate Professor, Mechanical Engineering Department, DISCHARGE. Now we are going to see the Unit 2, which is called Electrical Energy Based Process. In electrical energy based process, electrical energy is directly used to cut the material to get the final shape and size. It consists of two types. One is electrical discharge machining, which is called EDM, and another one is wire cut electrical discharge machining, which is called WCEDM. Now we will see the working principle of a EDM. In electrical discharge machining, which is also known as a spark erosion machining or electro erosion machining, metal is removed by producing powerful electric spark discharge between the tool cathode and the work material anode. This principle is followed in this process. This is the schematic diagram. Now we will see the construction of the EDM. Figure shows the schematic layout of the electric discharge machining process. The main components are the electric power supply, dielectric medium, workpiece, tool and servo control mechanism. The workpiece and the tool are electrically connected to a DC power supply. The workpiece is connected to the positive terminal of the electric source so that it becomes the anode. The tool which is connected to the negative terminal of the electric sources so that it becomes the cathode. The tool and the workpiece are submerged in the dielectric fluid medium such as paraffin, white spirit or transformer oil having poor electrically conductivity. The function of the servo mechanism is to maintain a very small gap known as a spark gap range of 0.005 mm to 0.05 mm between the workpiece and the tool. Now we will see the working of an electrical discharge machining. When the DC supply is given to the circuit, spark is produced across the gap between the tool and the workpiece. When the voltage across the gap becomes sufficient larger, more than 250 volts, the high power spark is produced, so the dielectric breakdown and electrons are emitted from the cathode tool and the gap is ionized. This spark occurs in an interval of 10 to 30 microseconds and with a current density of 15 to 500 amps per mm cube approximately. So thousands of spark discharge occur per second across the gap between the tool and the work, which results in increasing the temperature of about 10,000 degrees Celsius. At this high pressure and temperature, workpiece metal is melted, eroded, and some of it vaporized. In this way, the metal is removed from the workpiece. The removed fine material particles are carried away by dielectric fluid circulated around it. The metal removal rate depends on the spark gap maintained. If anode and cathode are made of same material, it has been found that the greatest erosion takes place at anode. Therefore, in order to remove maximum metal and having minimum wear on the tool is made as a cathode, the workpiece as anode. When the voltage drops to about 12 volts, the spark discharge extinguishes and dielectric fluid Once again, the dielectric fluid should be filtered before reuse so that chip contamination of the fluid will not affect machining accuracy. The dielectric fluid should be easily available at reasonable price. Next one is function of a dielectric fluid. The dielectric fluid medium which doesn't conduct. What is dielectric fluid? The fluid medium which doesn't conduct electricity. Dielectric fluid generally used are paraffins, white spirit, kerosenes, mineral oils. Must freely circulate between the workpiece and tool which are submerged in it. Eroded particles must be flushed out easily. Should be available at reasonable price. Dielectric fluid must be filtered before reuse so that the chip contamination of a fluid will not affect machining accuracy. Function of dielectric fluid. It acts as an insulated medium. It cools the spark region and helps in keeping the tool and workpiece cool. It carries away the eroded metal particles along with it. It maintains a constant resistance across the gap. It remains electrically non-conducting until the required breakdown voltage has been reached. It breaks down electrically in the shortest possible time once the breakdown voltage has been reached. Tool material and tool wear. The tool material generally used can be classified as a metallic material, which is called copper, brass, copper, tungsten, etc. Next is non-metallic material, graphite, and combination of metallic and non-metallic material is copper and graphite. The For commercial applications, copper is the best suited for fine machining, aluminum is used for die sinking, and cast iron for rough finishing. The three most commonly used material are given. One is copper, graphite, and copper tungsten. Graphite is a non-metallic which is generally used as a tool material in electrical discharge machining process. A wide range of grades are available in graphite, and these are used for variety of applications. A big advantages of a graphite is through it is a abrasive. It can be produced by several methods like machining, molding, milling, grinding, etc. Graphite can generally achieve better metal removal rate and fine surface finishes than metallic tool material. One disadvantage of a graphite is it is costlier than copper. Copper. Copper is a second choice for using as a tool material in electrical discharge machining process. It can be produced by casting or machining. Copper tool with very complex features are formed by chemical etching or electroforming. Copper tungsten. Copper tungsten tool material is difficult to machine and it has low metal removal rate. It is costlier than graphite and copper. The selection of a proper tool material is influenced by size of the electrode and volume of a material to be removed. Surface finish required. Tolerance. Nature of a coolant application, etc. The basic requirement of any tool material are it should have low erosion rate. It should be electrically conductivity. It should have good missionability. Melting point of the tool should be high. It should have high electron emission. Tool wear. As the tool does not come into contact with the work life of the tool is long and less. Long and less wear and tear take place. The tool ratio is defined as the ratio of a volume of a work material removed to the volume of the electrode tool consumed. Next is factors affecting the material removal rate. Metal removal rate increases with forced circulation of dielectric fluid. It increases with capacitance. It increases up to optimum value of work tool gap. After that, it's drop. It increases up to optimum value of spark discharge time. After that, it decreases. Metal removal rate is the maximum when the pressure is below the atmospheric pressure. Various circuits used in EDM power generating circuit is power generator is one of the most important part of an electrical discharge machining process. Its primary function is to convert an alternate current AC into a pulsed direct current DC, which is required to produce the unidirectional spark discharge between the gap of the tool and workpiece. A rectifier is used to convert the AC into DC. The most commonly used spark generating circuits are given. Resistance capacitor circuit, RC circuit. Second one is RCL circuit, resistance capacitor inductance. Third one is rotary pulse generator circuit. Fourth one is controlled pulse generator circuit. First we will see about the relaxation circuit, which is called resistance capacitance circuit. Figure shows the operation of a resistance capacitance RC generator circuit. This type of a generator are quite commonly because of its simplicity and lower cost. In this system, direct current DC is flowing through a resistor or and it charges the capacitor C. The charged capacitor is connected to the machine. When the voltage across the capacitor is sufficiently high, 50 to 200 volts, dielectric medium breakdown occurs. So the dielectric medium between the tool and the workpiece is ionized and spark takes place. Millions of electrons are developed in each spark. During sparking period, the voltage falls and it again starts rising since the capacitor is charged again. Energy released per spark equal to E equal to 1 by 2 into C into V D square. C is the capacitor value, Vd is the discharge value, and drawback of relaxation circuit is through the discharge current in a relaxation circuit reaches a high value, it is of very short duration. Since the time for charging the capacitor is high, the use of the high frequency is limited. Next one is RCL circuit. This is called RCL circuit. RCL circuit. In the relaxation circuit, metal removal rate increases as R is decreased, but R cannot be decreased below a critical value. If R decreases below a critical value, arcing will take place instead of a spark. Further, the capacitor charging time is RC circuit is much higher than the discharge time. Therefore, an inductance L is included in the charging unit. Next one is rotary pulse generator. The introduction of a pulse generator has overcome the drawbacks of RC and RCL circuits. RC and RLC circuits yield low metal removal rate. Therefore, rotary pulse generator is used for spark generation. It yields high metal removal rate, low tool wear, and more precise control of parameters. Figure shows the schematic diagram of a rotary impulse generator circuit. In this circuit, the capacitor C is discharged through the diode during the first half cycle. During the next half cycle, the sum of the voltage generated by the generator and the charged capacitor is applied to the work tool gap. This arrangement gives more metal removal rate, but surface finishing is poor. Next, last one is control pulse generator circuit. Figure shows the arrangement of a control pulse circuit. RC, RCL and rotary pulse generator circuit are not having automatic prevention of the current flow. In case a short circuit is developed, to obtain such a automatic control, a vacuum tube or a transistor is used as a switching devices as shown. Next is process parameters. First one is operating parameters. Electrical energy, voltage, time intervals, instantaneous current, torque, pulse width. Based on the above consideration, it is well understood that the MRR and TWR, material removal rate and tool wear ratio, are governed by the following: energy content of the pulses, the rate at which the energy is supplied, servo sensitivity, gap width, and dielectric parameters. Next one is taper. Taper effect is observed due to the side spot which is shown. Under high dielectric pollution, side spots are more pronounced as compared to the frontal spot. The formula is Tp equal to C3 into pi by 4 into D square. Surface finish. The surface finish of the material depends upon the following factors: energy of the pulse, frequency of the operation. The roughness of the material is observed within a bandwidth depending upon a single or a multi-spark conditions. Current density. The current density is the most important parameters which determine the material removal rate and surface condition. Current density is affected by either changing the current or changing the electrode tool workpiece gap. When the current is increased, each individual spark removes a larger crater of a metal from the workpiece, but it also increases surface roughness, increases spark frequency, results in decreases in surface roughness and reduces the removal of crater of metal from the workpiece. The gap between the electrode tool and workpiece is determined by the spark voltage and current. A small gap produces more accuracy with a better surface finish and slower metal removal rate. Characteristics: metal removal technique by using powerful electric sparks. Work material: electrically conductive material. Tool material: copper alloy of zinc, yellow brass, copper tungsten. MRR: 15 to 80 cubic mm per second. Spark gap: 0.0052 to 0.05 mm. Spark frequency: 200 to 500 kilohertz. Volts: 32 to 50 volts. Current: 5 to 60 amps. Temperature: 10,000 degrees Celsius. Dielectric fluid: petroleum based HC fluids, paraffins, white spirit. Applications: production of a complicated, irregular shaped profiles, thread cutting in jobs, drilling of microvolts, helical profile drilling, curved hole drilling, resharpening of a cutting tools and broaches, remaining remachining of a die cavities without annealing. Recent development in EDM is EDM change from using relaxation circuit to faster and more efficient impulse circuit. Instead of using copper, tungsten carbide is used as a electrode. Advantages: it can be used for machining various materials such as tungsten carbide, electrically conductivity material, and other hard materials. It gives good surface finish. Machining of very thin section is possible. It does not leave any chips or burrs on the workpiece. It is well suited for complicated components. Since there is no cutting force act on the job, error due to elastic deformation is eliminated. High accuracy is obtained. Fine holes can be easily drilled. It is a quicker processor. So order material can also be machined at much faster rate than conventional machining. The process once set up does not need constant operator attention. Disadvantages: it is only used for machining electrically conductivity material. So non-metallic such as plastic, ceramics or glass cannot be machined by EDM. It is suitable only for machining small workpiece. Electrode wear and overcut are serious problems. Perfectly square corners cannot be made by EDM process. Metal removal rate is slow. Power requirement is very high. In many cases, the surface machined has been found to have micro cracks or holes. Thank you.